All right, so now we're going to talk about tangent substitutions. So we have an integral that looks a little different. It's not 1 minus x squared. We've now got x squared plus 9. But so if we take that Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And if I just divide everything by cosine squared, right? Everything divided by cosine squared. Cosine squared. What I end up with is tangent squared plus 1 equals secant squared theta. Okay? So you may have memorized that this as another Pythagorean identity. I honestly I only remember the one, and then I if I need it, I know it exists, so I know how to get it. But I always like to check myself because I always forget. Is it what? I can never remember for sure. What I always like to derive it. So, and now in this case, so we've got something that looks like, I've got x squared plus 9, right? So we got something squared plus a constant. So what I can do here is let x equal 3 tangent theta. Okay? So I'm going to try to turn this denominator into something that I can apply this Pythagorean identity to. All right. Now, don't forget, we also have to transform the dx. So let's do that too. And what we'll end up is 3 secant squared theta d theta. Okay, so let's plug all that in. We get integral of 1 over, and I'm going to square x, which is 3 tangent theta, so I get 9 tangent squared theta plus 9. Okay. And then times dx, which is 3 secant squared theta d theta. All right? So now let's simplify this a little bit. I can factor out a 9 here. So that's why I chose the 3 tangent theta instead of just tangent theta, because I wanted to be able to factor out the 9, and then I will get something that looks like tangent squared plus 1. So I'm going to have basically 1/9 times 3, so I'm going to get 1/3. I'm just going to pull that out front, 1/3. Okay, if I combine that 1/9 with the times 3. And then what I end up with is 1 over tangent squared plus 1, and then times secant squared theta d theta. All right, now we know what tangent squared plus 1, whoops, I forgot my theta. We know what tangent squared plus 1 is, right? I'm going to actually clean this up. Forgot to write theta plus 1. All right. That's secant squared. Okay, so we end up with 1/3 integral of 1 over secant squared theta times secant squared theta d theta. Right? And the secant squareds will cancel. All right, so again, we've just got integral, we get 1/3 integral of 1 d theta. Okay, and that's just 1/3 theta plus c. All right, so then we got to go back to x. So we let x be 3 tangent theta. So tangent of theta is equal to x over 3. And then theta is the arctangent. Arctangent of x over 3. Okay, so our final answer is 1/3 arctangent of x over 3 plus c. And there you go. So we can do the same thing, we can do a similar thing, I guess, with tangent. So the next one's a little trickier. You can go ahead and look at it, think about it, but I'm going to show you some more techniques that you'll need to know to solve these problems.